All right, let's go.
30. Well, we leave the track at 1, but we get released at 12:30.
Okay. Same as normal. Let's see, no. Find
Is this a title?
the, confidence interval for population. Okay, the last two sections we were finding the confidence interval for the population mean. Now we're going to switch. Now we're going to find the confidence interval for the population proportion. Proportion is the new word. And the symbol for population proportion is P, capital P. Actually, it could be lowercase p too, it doesn't matter. Okay, and we're going to do this by hand and by program. So let's go with by hand. Okay, first. Okay, and it will only be z-scores today. And the first step is to check to make sure that the sample size is large enough. And it's not the magic number 30 here. That only applies when we're doing means. So first, you want to check to see if the sample size is large enough to make a normal distribution. And the check is your sample size times p hat. I'll have to tell you what p hat is in a minute.
That's the what?
P hat. That's the symbol for p hat. And you need the sample size times p hat to be greater than or equal to 5. And you need the sample size times q hat to be greater than or equal to 5. If both of those are greater than or equal to 5, you can continue on and do this problem.
And the hat mean what?
I'll tell you in a minute. It just means that it's the percentage from the sample. I'll get to that in a minute.
That's pretty quick minute.
Yeah. But I'm going to actually write it out.
Oh.
Okay, well actually I'm going to write it out right here. So, what is, you're going to be finding, obviously you got to find this first, but find the point estimate of the population proportion okay, and the point estimate of the population proportion is the sample proportion. The sample proportion is called p hat, and what you're going to do is take the x, which is the number of successes, divided by the sample size. So it's number of successes divided by the sample size. So if we were studying what percent of the American adult population is over 6 feet tall, we're looking for a percentage of that population. And what we're going to do is take a random sample and see what percent of our sample is over 6 feet tall, or whatever we're studying. So that's your p hat. So what do you think q hat is? The leftovers, the ones that's like failures. So if x is the number of successes, q hat will be the percent of failures. Okay, So then your third step is to calculate your max error. That's big E. And the formula here is the z-score for your confidence level multiplied by the square root of p hat times q hat over the sample size. And that whole fraction is under the square root. It's multiply. And then the fourth is to write your interval. And this interval is for the population proportion. And population proportion symbol is just P. And what we're going to do is say take that P hat value that we found that estimates the population value, add and subtract your max error. All right. I got one little, I forgot it in here, of course. In step 2, got a little, you can just put it off to the side. Off to the side if you need to. If P hat is not known, use P hat equal to 0.5. Because that will maximize the error. All right. So, we're going to run through one by hand. Yep. We're going to do one by program, and then we're going to have a minimum sample size formula. I got to get my book out anyway to get the example. Let me go. We're in. Oh, I got the calc book. No wonder I can't find them. Wrong book. Wrong book. Six, 3. Example 1. Construct a 90% confidence interval for the proportion of adults who say that of all the presidents in our nation's history, they most admire Abe Lincoln. So I'm not going to write all that out. So construct a 90% confidence interval for the proportion of adults that like Abe Lincoln.
Well, can't you just say that like tacos?
The best. Okay, that's fine. So I got to get our survey results. Let's see. Where is this data coming from? Oh, right here. They did a survey of 1,470 adults. And 98 chose Lincoln. Okay. So first off, on a test when they're all mixed together, how do you know what section to go to on your note card? Well, read it and see what confidence interval you find. We are constructing a 90% confidence interval for the population, or for the proportion. Key word here, population proportion. So you know what to come to this section of the notes. So we're looking for big P. All right, so we're going to go through our 4 steps by hand. So our first step, just following the 4 steps I just gave you, we first have to make sure that the sample size was big enough, where we are going to go n times p hat and n times q hat to make sure that they're both greater than or equal to 5. Where am I getting n from?
The number you served.
The sample size. How big was my sample? It was pretty big. 1,470. P hat is a proportion or a percentage or a fraction. What fraction of my sample picked Abe Lincoln? 98 out of 1470. So this example, they gave us the separate values. I'm going to do another one too where they don't. So what happens here? What do we get for an answer? 98. So that's definitely over 5, so that's okay. What about n times q hat? N is still 1470. Q hat is the number of failures, so how many did not pick Abraham Lincoln out of the 1470?
1,372.
1,372. And we're going to get 1,003.
You got 1470.
Oh, I don't know. I must have been looking at that 98. And that's definitely over 5, so we're good to go. If either one was less than 5, can't do, move on to the next problem. Okay, second step was to find the point estimate, and we already did. Yes?
Are they always going to turn out like even like that
Yes.
for the end?
Well, if they give it to you, I'll show you in the next one where they won't, but what we have to do is round them to something that is.
But do you know what I mean? Like,
Yes,
Okay.
yes, they should. So, the next one, the second step said find p hat. Well, we already did that. What was our p hat? As a fraction, it's 98 out of 1470. But like anytime they give these percentages, they usually give them as decimals or percents. So what is 98 divided by 1470? Because I don't think it comes out nice and neat, so that's why I put the approximate in there. About 0.07,
Yeah.
about 7%. Okay with that? So that's what we're going to use in our little interval in step 4. So now, our third step is to calculate the max error. Big E. So, the big E formula says we need the z-score for 90%. Anybody memorize it yet?
Nope.
I think it is 1.645. Is it right? Yes. Let me check. Yes. And then it says take the square root of p hat times q hat. Okay, I'm going to go back to my fractions though because I have them. It doesn't matter if you use fractions or decimals. If I use fractions, I'm going to be more accurate instead of using this rounded off decimal, but I don't care. The process is take p hat, multiply by q hat, divide by n. So my two fractions are 98 out of 1470. And the q hat you told me was 1372 out of 1470. Divide by the sample size of 1470. So, what makes this problem hard is the calculator part. Type that in and get the right answer. That's the challenge here. The plugging the numbers in is pretty simple. This here, very challenging now. Impress me with your calculator skills. There's many ways you can do it. You can do it in little pieces.
No, I'm gonna do it.
Wait and write it down.
I'm just not gonna do it.
Yeah, I knew you wouldn't.
I'm gonna wait till you do it.
I know.
Then I'm gonna do
You're just going to write it down.
it. Exactly. I just did a lot of practice.
I'm going to go with that.
Hey, that's what I got.
Yeah, me too.
Me too.
Just because it's so confusing, like around like the bottom, like the 1370 thing, does that like change it?
No, did you get my answer?
No. But I have everything else, but I just put parentheses on like this down there.
It changed it then. So they're not needed because there's only one number in the denominator, so you don't. It doesn't need an extra set of parentheses.
That's so much work to just get 0.01.
1%. So if we were to survey the entire adult population, oops, this is fourth, yep, fourth step. We would expect that the average number of people to pick Abe Lincoln to be between 0.07 plus and minus the 0.01. So that's between 6% and 8%. Okay, I do want to do another one where they give you the different information to start with by hand, just because they can give you. So here I told you the number of successes and the sample size. Watch what happens here. Example 2.
This to be as long as the other.
No, not quite, shouldn't be. Let's see. You wish to estimate with 90% confidence for the proportion. There's our key word that tells us to come to this section on our note card. Of adults age 18 to 29 who have high blood pressure. In a previous survey, 4% of adults had high blood pressure. So 4. Have high blood pressure. And this is just up to age 29. So these are young people with high blood pressure. Let's see. Oh, sorry. Gosh, no. I was reading the wrong example, though. Ah, dang it. Oh, I'm going to try and fix it, though. Let me make some stuff up. Let's see. Let's see. And then the sample size was, I'm totally going to make this up. 500 people. Okay. All right. So the four steps. So the difference is, well, you're going to see. Is their sample size big enough? I need to check N times P hat.
So are we're solving for a population?
Proportion, yes. Yes, it's what I expect. So based on this sample of 500 people with 4% having high blood pressure, if I was able to get the blood pressure of all 20-year-olds, what would be the percentage that I would expect to have high blood pressure based off of this sample?
Are we going to be doing a sample proportion?
We are basing our population proportion on the sample. Let's just go with it.
Okay.
Okay, what's our sample size? 500. What's my p hat? Remember, p hat is a proportion of the sample. The proportion of successes. How many successes did I have having high blood pressure? It's 4%, 0.04. So this time I didn't give you how many, I gave you the actual percentage. Where in the first example, I took the number
So you don't have to put that over?
and made a fraction, a percentage out of it as a fraction. Where this time I'm just giving you it as a percent, so you have to use it.
So you don't have to put it over?
Because it's already as the decimal. So how many had high blood pressure? 20? And then N times Q hat is 500 times, what percent don't have high blood pressure? 96%. That must be 480. So we are good to go. So p hat, I say find p hat because we're going to use it in our interval. I gave you p hat in the percent. So 4%. Where in the first example we had to actually divide to get the decimal. So they can give you the information one of two ways. Tell you how many successes or give you the percent of successes. And now our third step is to calculate max error. And that formula said take the z-score for 90%. Oh, we never multiplied by the 1.645, did we? Or did I?
Yeah.
Okay. Whew, I had a panic attack. 1.645 times by that square root. It's p hat times q hat. This time I have those as decimals. So I'm just going to go with it. 0.04 times 0.96 over the sample size 500. This one shouldn't be quite as challenging because it has nice decimals in it. Let's see how best you can do this time.
No, I just forgot to do the 1 point.
Oh, that what you forgot. I thought I forgot it too, but apparently not. Oh, 1% again? So then our interval for the percent of the population that will have high blood pressure is between 3 and 5%. Okay, now the last one is by program. Oh, I shouldn't say last, got one more thing. So proportions, I'm just going to say program here. Oops. The program is called you're going to go under Stat, over to Tests, and you are going to look for one prop Z int. So prop for proportion, Z interval. Okay, and I do want to do new data because there's something special. I'll make sure I get the right one this time. Number 3. Okay. Example 3. So let's see. Survey 935 adults. Who think that trains are the safest? Let's see. 16% say trains are the safest transportation mode. Construct a 99% confidence interval for proportion of all adults. So, proportion being the key phrase in there, telling you to use your one prop, the int. So let's see what's in that program. Don't pick the one prop Z test. All of the first 6 programs are tests. We're going to be using those in the next chapter. Make sure you get down to the intervals. 2 samp, 1 prop Z int. I'm all the way down to A on mine. Everybody find it? 1 prop Z int. Okay. It only wants 3 things: X, N, and the confidence level. What did X represent in this whole situation here? The number of successes. Did I tell you how many successes were in this one?
Give us the percent.
I gave you the percent of successes. How do you get from the percent of successes to the number of successes?
60% times 99.
Yeah, to get X, you're going to take 0.16 and multiply by 935. And I think you can do it right on this line. Let's check. 0.16 times 935. When you hit enter, now let's think about that. Could I possibly have had 149.6 successes?
No.
No. This is probably rounded off. So how many successes do you think I actually had? 150. So you are going to have to go back and make X a whole number. If you try to run it with the decimal, it'll probably give you an error and say, you don't know what you're doing. There's no way you had 149.6 successes. We probably had 150, which rounds to the 16%. Sample size, though, was 935. And we're doing a 99. Calculate. Why does it say error? You didn't change your decimal to a whole number. So it's between almost 13% and a hair over 19%. I think the book does go 3 places on their percentages. You can see they give you the p hat down there. See that 0.1604? It was rounded. So the one thing to remember is that, maybe we should say it back here. Little X must be a whole number. That's all you've got to remember on your program. And then it's pretty straightforward.
draw top hats instead of regular hats.
You can draw anything you want, because I will know what you mean. All right, last thing is minimum sample size for proportions. Minimum,
How much is this gonna take?
a little bit of algebra. About 5, 6, 7, 8 lines. So we had a minimum sample size when we were working with population mean. Now we're going to do one for population proportion. And all we're going to do is take that big E formula and work it backwards and solve for the N. So let's practice that algebra because it's a good skill to have. And work it backwards for N. And I would just write down the N equals formula on your card. So to calculate big E, we take the Z-score. P hat, Q hat, over N. All right. Our goal is to solve for N. What are you going to do first algebraically?
Move the Z.
I would move the Z. How would you move the Z? Divide both sides by the Z. Good call. That's gone. Now what would you do? Square both sides to get rid of that square root. So we're going to have the fraction E over Z squared equals, and then here the square root's going to be gone, P hat times Q hat over N. This one's a little tricky. What's next? We don't want that N in the bottom of the fraction. How are you going to get it out of there? Multiply by N on both sides. So the N's going to cancel. Now I want to leave the N here. I want to get rid of this fraction. What's happening between the fraction and the N? So what's the opposite of multiplication? Divide. We're going to divide by that fraction. How do you divide by a fraction in junior high?
Multiply by the reciprocal.
Multiply by its reciprocal.
What are we trying to find?
N. And you won't have to do these steps again. I just wanted to practice the algebra. So over here we had the P hat times Q hat. And we're going to multiply by the reciprocal of my fraction. So I'm going to flip it over. So it'll be the Z score divided by the error squared. And this is where we want to stick in there. If P hat is not given, use 0.5. This is where I wanted that. I knew it was somewhere. P hat is not known. Use P hat equals 0.5. That's where I wanted that dumb thing. Okay, and this is number of people, remember, so we always have to round up. So our last example. Okay. Okay. This is it. Are we on 4? Yep. Find sample size needed to be within 4% of the population proportion if you are doing a 92% confidence interval. That's it. Okay, so we just did the formula. We need to know 4 things. P hat, Q hat, z-score, and the error that we're allowing. Okay, I gave you 2 things. Let's identify what they are. What is this 4% that I'm giving you if I want to be within 4%? Which letter is that I gave you? Is that P hat, Q hat, z-score, or the error that we're allowing?
Error.
Go.
That is the error we are allowing. I'm allowing myself to be within 4% of the actual percentage. So that within, anytime you see that within, that's the leeway. You got to be within this much. That's how much error we're going to allow. This is big E. Okay, got that done. This 92% is going to help us find the z-score. I didn't give you one of the common ones because I wanted you to remember how we calculated this. How do we get the z-score for 92%? Do you remember what we did? 92% is in the middle of my interval. How do we get the positive z-score even though we usually find the negative one first?
You just do inv-norm.
Inv-norm of what?
Area.
The tail. What's in the tail? 4%. Oh, I don't like that matched that, but we'll go with it. My tail piece is matching my max error. That's usually bad in an example to have that overlap. But it is what it is. So if you do the inv norm there,
1.75.
1.75. Okay. So to figure out the sample size, we still need to know P hat and Q hat. There's no more given information. What do we do?
Split.
Nope. Use 0.5 for P hat. Sometimes they will give you a sample percentage and you would use it, but in this case I did not give you one. So if they don't give you, you're going to use 0.5 for P hat. What does that make Q hat? 0.5 also. Then I need that fraction. Z-score, we figured 1.75, or Matt figured.
So P and Q are the same?
Because they add up to 1. Success and failure just subtract from 1, so just because it's 0.5. And then the error we are allowing is the 0.04. We've got to square that fraction. For some reason, people forget this on the test, the squared. So how big of a sample do I need to pull off the 4% error? So we need 479. Even if it was 478.01, it would still be 479. Okay, now I'm done. What do I have for you? Yes, on sample size, it's a whole number. Okay. Page 280. Ten through 24 even. Let's see how many of these are confidence intervals. 3. Sample size, sample size, sample size. Okay, so that's all sample size. There's that. So 1, 2, 3, 4, 5. There's 5. Let's go 3 by hand. So 10, 12, and 14 by hand. And then your other confidence intervals are 16 and 22.